Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with day 3 of 5.1, which is application of quadratic functions. So we learned about standard form, vertex form, and factored or intercept form of quadratic functions of parabolas. And now we're going to be applying it to some actual real-life examples. And quadratics or parabolas are very useful for tracking the flight of an object through the air on Earth. It follows a quadratic or parabolic, track, or I can't think of the word right now, that's okay, but the way that it follows, if you were to throw an object through the air to someone else, like a ball or some other kind of thing, it will follow a parabolic path, I guess is the word I was looking for. So we're going to be doing a few different examples here. We're going to do one of each type of standard form, vertex form, and intercept form, and we're going to be looking at different examples of real-life parabolic applications. So example 1 is the path of a ball thrown by a baseball player forms a parabola with the equation y equals -3 over 2401 times the quantity of x minus 49 all squared plus 8.5, where x is the horizontal distance in feet from the player and y is the height of the ball. All right, so we're going to have a baseball player. Well, the first thing we should do is figure out what kind of type of equation we have here, and also if it's open up or open down. So what equation does this look like? So this is standard form. We'll put this up here. That's standard form. We also have y equals a times x minus h squared plus k. This is vertex form. And then we have y equals a times x minus p times x minus q. And that's intercept form. So, which equation does this one look like it's following here? Well, hopefully you said vertex, because it is vertex form. So we know it's going to be vertex form. And we also know that is it open up or open down? What letter in all these different equations is going to give us whether it's open up or open down? It's the a value, and if a value is positive, it's going to open what? Positive, it's going to open up, and if it's negative, it's going to open down. So this one, here's our a value. Is that positive or negative? It's negative, so it's going to open down. That's not good. Let's fix that. It's going to open down. Okay? So we have a path of a baseball player. So he's starting at a certain height. So y is the height of the ball at any given point. This is our y axis. This is our x axis. So it's going to start somewhere above the ground, right? When a baseball player throws the ball, he doesn't throw it from the ground. He's going to throw it a little bit above the ground, right? So it's going to follow some kind of path like this. And at the end of it, it says where we're looking for. So the things we're looking for is how far does the ball travel before it reaches the same height from which it was thrown, and how high was the ball at its highest point. So the same height would be over here, right? It's going to be the same height. We don't know what the height is, but it's going to be the same height. It's going to be the mirror points that mirrors the starting point of how tall the baseball player or how high he threw it from. Okay, so we're also going to be looking for, we need a vertex. Vertex is pretty important for all of these kind of problems. And then we also have, this is the axis of symmetry. Okay, we don't know what any of these values are going to be. We're just going to draw a general picture to get an idea what's happening here. Does that look like, if you're a baseball player might throw it a little bit more shallow. It might be a little bit of a wider parabola. I'm just drawing it so we can actually see the different parts of the parabola. All right, well, it's asking for the vertex first. Well, if this is in vertex form, what's our vertex going to be? Well, h is going to be, it's x minus h, and then k is going to be our 8.5, so it's literally going to be 49 and 8.5. So that's going to be our vertex. So up here, the vertex is the highest or the lowest point. If it's open down, it's the highest point. If it's open up, it's the lowest point. So our vertex is 49, 8.5. Well, this helps us answer one of our questions already. It says, how high was the ball at its highest point? Well, the vertex is, like I said, the highest point of an open-down parabola, so that's easy. So it's going to be, was it 49 or is it 8.5? Well, if you look at x is the horizontal distance and y is the height of the ball. So it's going to be 49 or 8.5 is going to be our highest point. It's going to be 8.5 is going to be our highest point of the at the ball. 8.5 feet. Okay. So that's that. And now we're looking for, it says how far does the ball travel before it reaches the same height from which it was thrown. So from here, so we're going from where it started right here and we're ending over here, right? Okay. So my question for you, if we make an X and Y table here, we're only going to do 3 points though. We're only going to do 3 points. So we know the middle point is going to be 49 and 8.5. Okay. What other x value do we know? Well, we know the starting point right here is when y equals 0, right? So we're going to plug in 0 into this equation. We're going to plug in 0 into this equation up here, the original equation. Okay, that's how we do it. Once we find, so we normally would pick like 48 and 47, but we're looking for the end point. We're looking for where, we're looking for like how far the ball travels before it reaches the same height which it was thrown at, which is going to be this end point over here. So you could do like 49 all the way down here and do all this. Those aren't really useful points in this case, okay? So we want to work smarter, not harder. So we're going to plug in 0 in for the x value. We're going to plug it into this original equation, and we're going to get 5.5 once you plug that into a calculator, which is, I wouldn't solve this like by hand. I would use a calculator, honestly, if I were doing this. So for 0, it's going to be 5.5. We also know it's going to be 5.5 when it ends, because it's got to be a mirror image on either side of the parabola. Now, how do we figure out how far, what this value is right here? Well, a parabola is symmetrical, right? So we know from the center, from the beginning point to the center is how many feet? How many feet is the x value of the vertex? Well, it's 49, right? So because parabolas are symmetrical, it means the other one also has to be the same. That was a bad curly bracket. Dang it. This also has to be 49, right? Because a parabola is symmetrical on both sides, so the distance from the parabola to one point has to be the same on both sides of it. So what's 49 plus 49 going to be? Well, that's going to be 98. So this is going to be, our final answer is going to be 98 feet. Okay? So the parabola you're probably going to use for most of these problems, but you got to be careful about what it's asking for, okay? If it's asking for the highest point, you're probably going to use the vertex. If it's asking for, like, how far did it travel or something like that, for in this case, we're looking for to go from here to here, how far was the horizontal distance, right? And we know we have to be careful and be detectives about this stuff. So we know that from the beginning point to the center was 49 feet because that was our vertex. And from the vertex to the end is also going to be 49 feet because they have to be symmetrical. And then we just add those up and we get 98 feet. Very challenging stuff. Just stick with me. These are really tricky problems. You know, these are word problems with a very hard concept. So just don't panic. We'll get through this together. All right, let's do this. Okay, number 2. A survey was conducted to determine the number of hours of study that leads to the highest score on the mid-year exam, or year-end exam, that is. The exam score Y for each student who studied for X hours can be modeled by Y equals negative 0.853X squared plus 17.48X plus 6.923. Okay. So first things first, we got to figure out if it's open down and open up or open down, and also what form is it in. Well, let's take a look at this. What form does it look like it's going to be in? Hopefully you said standard form. This is going to be standard form because it's ax squared plus bx plus c. Standard form, and is it open up or open down? Well, the a value in front of the x squared is negative, so this is going to be open down. Okay, so we're going to draw another, well, let's not draw it yet. Let's go ahead and figure out, we'll approach this one a little bit different way here. Okay, so we need to figure out the vertex. What's the x-coordinate of the vertex in standard form? Hopefully you said it's the opposite of b over 2a. So we need to figure out our a, b, and c. A equals negative, let's write it over here actually. A equals negative 0.853. B equals, what's in front of the x is 17.48. And C equals 6.923. Kind of sloppy, but I wanted to be sure we fit it there. Okay, so we're plugging in negative b over 2a. So opposite of b is negative 17.48 over 2 times a, and a is negative 0.853. Which is going to be, and then we gotta be careful here when you're doing this, all right? So this is going to be equal to, if you do that math, you multiply 2 times negative 0.853, and then on Desmos, let's see if I can open Desmos on here real quick. Do I have Desmos handy? Yes, the Desmos scientific calculator. Let's go ahead and do this math really quick, and I'm gonna show you a shortcut to help you figure out how to do these. So we have negative 17.48 divided by 2 times negative 0.853. All right. So on the right here, we have our answer, which is 10.24, 10.25. If you hit this, this is the exact answer. This is a fraction, which is going to give you an exact answer and not a decimal approximation. So then you can go back to the other one if you need to. That's just a really useful tool. I would really highly encourage you to use Desmos Scientific Calculator. It is very useful. So the exact answer is equal to 8740 over 853, but it's approximately, when you round, it's going to be approximately 10.25. So you want to think about what this problem is asking for. Do you see how these are all decimals to start with? It wouldn't make sense to go from decimals to a nice, really precise fraction for this problem exactly, because it looks like they were all kind of approximations to start. So we can just stick with 10.25. So our x-coordinate of our vertex is 10.25. The y-coordinate of the vertex, we need to take that. We need to plug 10.25 into the original equation. So negative 0.853 times 10.25 plus 17.48 times 10.25 plus 6.923. That's going to be approximately, again, actually it's going to be equal to, if you plug that into your calculator correctly, it's going to be 308,719 over 3,200. So that's going to be approximately equal to 96.47. If you want me to plug that into your calculator, I'm not going to plug it all into the calculator. Just plug it in exactly as it looks right there. That should be the answer that you get. So 96.47. Okay. So we have a graph now. So it says, let's see here. So we're looking for a parabola here. We need to think through what this means a little bit, okay? It's probably not going to start at 0. I mean, you guess you could get a 0 here, but if you plug in 0 into this original equation here, these are going to go to 0, these are going to go to 0. Our lowest score we can get without studying at all is going to be 6.923. That's going to be our starting point. It's going to be, let me zoom in a little bit, 6.923. Okay, no matter how little you study on the for the year-end exam, that's going to be your starting point. Our parabola is going to go like this. Oops. We're just drawing a general graph to get a idea what this is going to look like. It actually might be more steep. Let me make it more steep. Because we got to go from 6.923 up to our vertex, which is 10.25 and 96.47. So this is our vertex right here. It is 10. Let me make an axis of symmetry first. So our vertex is 10.25, 96.47. So what does that mean? It's saying what amount of studying produced the highest score on the exam? Okay. Well, the highest score on the exam would be at the vertex of the parabola, right? This is the highest that the graph goes, so it can't be higher than that. So our highest score the score projects is going to be projects as 96.47%. And what amount of studying? So that we had x and y. I should have put what these actually represented over here. So for x, this was hours studying, and this was exam score. Okay, going back to this other one here, just so I forgot to write it down on the axis here, but this is going to be distance from player is the x, and then this is going to be height of the ball. Okay, I can zoom in there if you need to see that. So that was the x and the y values for that last problem. For this problem, it's hour studying and exam score. So the highest exam score you can get is 96.47 based on the, it's the vertex. It's the highest point of an open-down parabola. So then the amount of studying it took was going to be 10.25 hours, right? 10.25 hours. Now, does this parabola make sense? So if you study, for example, say this is like 17 hours, does it make sense you're going to get down to like 60% if you study 17 hours? For this one, the parabola doesn't, it probably makes sense to stop right here and then not include the rest of this stuff, because you know, the more you study, it's not going to become a worse score because you're going to be more prepared, unless I guess you study when it's going to be very like really late at night or something. But we'll stick with the parabola for now. But there's sometimes you want to think about what the graph means. Let me get rid of that. So for this case, the parabola, the second half of the parabola probably doesn't make too much sense, but we found what we need to find. So the vertex is a very important point of interest for a lot of these problems. So 10.25 is the hours, that's our x, and then this is our y. That yields a 96.47%, which is the highest score you can get according to this model, which is this equation right here. All right, one more example. Hard stuff. Here we go. This is example 2, but it's actually example 3. The equation for the height of an underground train tunnel is modeled by the equation where x is the horizontal distance in feet across the tunnel, and y is the height of the tunnel. And we have y equals -2 times the quantity of x minus 2 times the quantity of x minus 20. So is this going to be standard, vertex, or intercept form? Hopefully you said intercept form. And it's also going to be open up or open down. What's this -2 telling us? Is open down. So for this problem, we're actually looking for what the tunnel looks like. So for this one, yeah, so we're actually looking for what the tunnel looks like. So we're going to start like this. Here's the tunnel. So this parabola is actually going to represent like what the like if you were looking down the tunnel, what it's going to look like basically. Okay, so x, we have x and y. X is horizontal distance, and y is vertical distance, or height. Okay, so we need to find the vertex. Well, how do we find the vertex of something in intercept form? Well, we need our p and our q. So p, remember, it's x minus p times x minus q. So our p and q is going to be 2 and 20. So the x coordinate of the vertex, x equals p plus q over 2. So we have 2 plus 20 over 2, which equals 22 over 2, which equals 11. All right, so 11 is the x coordinate of the vertex. And we need to find the y coordinate of the vertex. So we're going to plug in y equals -2 times 11 minus 2 times 11 minus 20. We plug into the original equation, and we're going to get that it's going to be equal to 162. So what does that vertex mean? So here's our vertex right here. Just kind of a rough sketch. It's 11, 162. Well, the 11 is the horizontal distance, so that means it's going to be it's 11 feet right from here to here. And then we know that the height is 162. That's going to be how tall. So let's ask how tall is the tunnel? Boom. How tall the tunnel is going to be 162 feet. Right? Because that's the top of the tunnel is going to be the vertex. How wide is the tunnel? Well, we know that half the tunnel, because to get to the vertex is half the distance from here to here. And then from here to here is going to be the same distance, which is going to be 11. So we get 11 plus 11, which equals 22 feet. And there is our answer. So, general steps for this one. I would say you always want to find the vertex. And you always want to start by listing what form it's in and if it's open up or open down. The vertex is a very important point of interest for a lot of these problems. And also, another part that's kind of important is the distance from the starting point to the center and the distance all the way across. So you're just going to double it, basically, for whatever you have there. Anything else I missed here? I think drawing a rough sketch is a good idea, kind of like they gave you those graphs to kind of draw a rough sketch to figure out what this is going to look like. But so basically, this is what the tunnel is going to look like if you're looking straight down the tunnel, how big and tall it's going to be and how wide it is. All right, thank you for watching. Have a great day. We will see you soon.